And welcome to Service Mesh 101 Operationalizing Application with Mesh. I hope everyone is hearing me well. Just write down in the chat in YouTube if you're watching this online in YouTube, or if you're watching this in a platform for Container Days. This stream is for Container Day conference, and I hope you will enjoy this conference so far. And before we start, just to understand where we're going and where we're standing, write down in the comments when you're listening this, when you're watching this, write down in the comments where are you coming from, and what's your expertise with Service Mesh? Like if you're running Service Mesh already, or if you're considering which one, so just like make some noise in the comments. So I want to make sure that everything is working, so we're good to go. All right. Okay, so we will go into slides. This is going to be a few slides session, and after that I will show you with some demos and things like that. Microservice. When we develop the microservice, we usually spend much time talking about what the framework to choose or to implement this microservice, and how implement your logic quickly. However, in many cases, we forgetting about some of the important things because we need to focus on delivering functionality and delivering actual features to your application. We develop one microservice, develop few microservices. We start developing this stuff, but adding more features. They start talking to each other. Those services communicate. We will love this. We learned this for, I don't know, last 5 years, I would say. So in most of my talks that I did around the microservices, and most of the talks that I did for different developers in the different communities, I'll talk about development of microservices, how to develop those. And we start doing more. We're adding more microservices, and all of a sudden we start seeing more darker place. We start seeing place where it's not like shiny on the first picture when we just envisioned this architecture, when we just started this. So very quickly we can discover there's a bunch of places where we can find even some dead code, right? So we can find some of the pieces of functionality maybe doesn't work, and we discover this usually in production by accident and figuring out what is going on there. So very quickly our architecture looks like Pepe Silva, a map of looking to the things. So what we need to do with this? So what are we gonna do with all this stuff? We need to do something that help us to avoid all these problems. And usually developers like to focus on developing features. When we're talking about day two responsibilities, like how we're going to support this on the long run, what observability tools we're going to be used, how we enable security, and usually security is a very important topic, but usually it's afterthought. It used to be much more simple life, right? It was much easier when we're not doing any microservices. We were not doing any all these like modern architectures and things like that. So let's take a look how we can fix that. For those of you who just joined us, my name is Viktor Gamov, and I work as a developer advocate at a company named Kong. It's a cloud connectivity company. We're building tools and we're building platforms that allow you to run successfully your applications. We're taking care of things around your day two responsibilities. We're helping you by enabling and controlling the traffic that goes into your system by providing you with the Kong gateway, or how you can do the traffic inside your application and what things you can do. So all these things I will talk to today. If you want to reach out and ask any questions about the API management, DevOps, deployments, Kubernetes, and all this kind of stuff, please follow me on Twitter. I'm a very interesting person. You can reach out to me directly in the Telegram, which is very popular, the chat application, and you can also subscribe to my YouTube channel. At the end of this presentation, I also put some of the links where you can find more information about things, what I do, and somewhere you can find more content. So let's talk about what is service mesh. Like everyone is have this like a burning question, like, okay, so why he started with microservices? Like, it isn't supposed to be talk about service mesh. It's indeed talk about service mesh and the microservices and the things, the way how we change the delivery of the things in last couple years very much aligned with this concept of service mesh. Remember when I was talking about it was much easier back in the day, right? I was wondering how many enterprise architects we do have in the chat. Again, don't forget to hit that button and write down in the comments. I'm watching some of the comments that come in here, and I'm watching some of the comments that come in platform. And many enterprise architects remember this diagram. It's a three-tier classic Java blueprint application when it explains how you deploy your enterprise application. However, these days, this is not how it looks like anymore, right? So because you can deploy all these applications back in the day in one server, your database running, maybe if you have a budget to run this database in another server, your application server is running somewhere with your application, your logic, everything is together. Now, everything changed. Everything changed. We can run the front-end application absolutely separately, like only UI thing, because we have these single-page applications now. Our business logic can be spread across multiple different calls. We can call one business call can invoke multiple different beans, multiple different system. So in this particular case, we need to do something different. And some of the new types of connectivity emerged. So there's the thing where we need to think about how we control the traffic that comes into our system, how we control the things that will go into our application, and how we can protect this, how we can implement things around authorization, authentication. Inside the applications, remember when I was showing this like enterprise application diagram, those connections are very direct, right? Where like you know that your application requires this database, and usually admins will provide you a URL to this database. So if we go into the places where, for example, cloud, and in the cloud you don't know where your application is running at a given moment of time. In this case, you don't really know where your infrastructure is running, where your database. So you will be relying on some sort of service discovery. So you need to request some repository. Where is my database? And after that, this repository will return you some sort of result. And same thing with other components. We don't want to have we don't want to refactor our monolithic application just to end up in a situation where we have a distributed monolith, where all these components will be tied, and the calling the service, the external service will require to know like exact URL or exact some sort of location. You also want to rely on some sort of service discovery for finding other services, so the application would be resilient. And in many cases, it is maybe a couple years ago, it was not very popular, or people are thinking about this because they were like moving to cloud. But these days, your strategy, if you want to run like successful business and relying on the cloud infrastructure, you will be relying on cross-cloud connectivity. You need to expand some of the functionality of your application, not in one cloud or not in one cluster, but in many. So this is cross-cluster connectivity. So still, what is the service mesh? So essentially, it's the idea where your services would be deployed in the situation where they don't talk to each other directly, but they rather talking to each other through some sort of proxy, through some sort of conduit to manage this connectivity. And the fun thing is here, like on this picture, I will running a little bit in front of my train. But in this picture, you will see these small icons. Actually, this is logo of Envoy proxy, which is a software that is foundational for the modern service meshes. Many service meshes implementation use Envoy as a sidecar container. But the Envoy itself, it's if you go and find your thesaurus, whatever you're looking for, different synonyms for application. If you look for a proxy, you will see Envoy as one of the options. So essentially, Envoy and proxy is the synonym. But you can say, Victor, how it is different from we just like put a bunch of load balancers like we used to do with this in the past. If we want to provide resilient communication, we deployed our service, we brought in, I don't know, like Nginx, or we brought in like F5 or something like that. We bring some load balancer that handles some of the functionality for us. That's correct, and but it is just like not enough load balancers for every possible service. You potentially can, but this is not going to be very efficient from perspective economy. So you don't need so many load balancers inside your data center. And as a matter of fact, we started at Konk, we started this campaign kind of to eliminate load balancers within your data center, because of the service mesh can quite successfully replace this functionality, and it would be much more efficient to control your traffic over the things of service mesh. Think about this, like this particular picture, we're going to be make it smaller and multiply. So essential idea, not going to be load balancer. We remove load balancer, we'll still have a proxy that will be lightweight, observable, and super fast, that allows our services to communicate through this proxy, and something that will be sit on top of it to control it. I will talk about this in a few seconds. So why people adopting the service mesh? So they want to build. First of all, they want to open up the world of possibilities for different teams and allow the teams to use different languages, platform, tools, and so far and so on. So in this case, they will need to have a unified platform for connecting their applications. They need to have unified management tools for traffic management, for some sort of implementing practices from chaos engineering into application lifecycle. Not only how we're going to react if our production will go down, but also implement chaos engineering as part of engineering practices in organization. So we cannot say that our network is 100% reliable. We can put some budget for failures, and we can implement this as a part of the normal life cycle. So the application code will be dependent on this, or in this particular case, maybe some of the traffic policies that we will implement together with service mesh. You see, the security is very important topic, so that's why I'm talking this one, not the first place, on the second place. I'm just kidding. It is important topic, but it's not very pleasant topic for developers to talk about this. Yes, the InfoSec people want to enforce all sorts of security policies and provide these recommendations how to protect the services. Here's an interesting concept called zero trust. And zero trust concept came from the idea that when you're running this in environment that you not own, you cannot trust anyone. You cannot trust infrastructure, you cannot trust the incoming traffic. So you need to implement the mechanism that prevents some of the unauthorized access to the system. One of the de facto standard for implementing some of the bits on the wire protocol, implementing these zero trust principles, is implementing MTLS protocol between the services. If we want to access some service securely, we know that we can implement TLS. In this case, like client and server can communicate securely. But if there's kind of like a multiple services, in one case, this service will be client. In another case, this service can be server. So they need to have a nice policies to enforce this end-to-end security between the services on the network level, plus implementing some of the policies for authorization and authentication. And another important topic. Remember, when I started this conversation, your application functionality can grow very quickly, and it can become very dark place super quickly, because we have a super smart engineers to implementing many features every day, but without strategy for how to efficiently observe all these things, it would be very, very difficult to see like what is going on in the system at all. So the observability, security, and connectivity. This is 3 pillars for why the people adopting the service mesh. So let me talk a little bit about Kuma Mesh, which is open source project. It's a CNCF project, and as a matter of fact, it is one CNCF project that use Envoy as a data plane for this. Many people thinking like, okay, so the Istio, but Istio not CNCF projects. Istio belong to different software foundation. So Kuma is a CNCF project. You can go to the kuma.io. And what is Kuma? So it is a service mesh that is designed to be multi-tenant. From the get-go, from the design phase, it was the idea that there would be multiple things the one service mesh can host. It is universal. A friend of mine asking, like, what does it mean universal? Like, is it like Kubernetes is not universal enough? So for some environments, it is not. Some environments still want to be managed not through Kubernetes, but some other tools like a classical VMs. You manage them with Terraform, CloudFormation. You have some data centers that you run on bare metal. You still want to leverage all these nice things that Service Mesh gives you. So the Kuma also brings this into kind of, it makes it as a all these things make this as a first-class citizens. So not only Kubernetes, some other service meshes designed to be running only in Kubernetes, and they think that other world doesn't exist. And more importantly, the Kuma is actually created to be like a multi-zone. So essentially, you can run some of the part of your application in Kubernetes, some of the parts of your application in bare metal, and they can be managed as a one whole service mesh. And Kuma allows to do this. Control plane supports this. A little bit numbers in terms of like how the Kuma grows. Some people might not hear about this project because the evangelism at Google much louder, and people talk about Istio as kind of there is no other service mesh. But you will be surprised. There's at least 5 or 6 different implementations of service mesh. It's a service mesh as a pattern, and there are different implementations exist. So a few numbers about the Kuma for the Kuma. 2 weeks ago, or like, 2 weeks ago, Kuma's celebrated 2 years anniversary. So since its inception, over 2 years, there's a lot of things that happened. Current version is 1.3, and there's many people already using this in production. So go check this out, kuma.io. It's pretty cool stuff. Let's talk quickly about the architecture. So we're talking about the service mesh and how it integrates with application. So how the service mesh itself runs. So the heart of this, the most important thing here is our control plane. So our control plane, it's the brain of our service mesh. Control plane contains some of the configuration, and usually administrators who wants to enforce some of the policies, they connect to a control plane and configuring the policies there. And after that, the control plane will be responsible for propagating all these changes to data planes. And beauty of this architecture, even though if this control plane will go down, your application will not be affected because it will be running with the configuration that these data planes will include. So this data plane, what's called, it is an instance of or a container. If you're running this in Kubernetes world, if you're running this as a universal mesh or like running on the bare metal, those processes, instances of process named Envoy that I was talking about a little bit. And a Kuma control plane talks to Kuma data plane and updating the information about the control plane. Some of the things that Kuma stands on top of itself, it's an open source project. It stands on top of the work of many people. It's a very interesting coincidence that the last, I believe last week, Envoy celebrated 5-year anniversary. It started as a project that people developed at Lyft, and after that they donated this to CNCF Foundation, and now Envoy running in multiple other systems. So if you have a past knowledge about Envoy, you do have some knowledge how the Kuma works with this Envoy. Envoy provides some of the interesting capabilities. Its L7 protocol works well with TCP, with HTTP and some of the protocols that runs on top of HTTP works well. It has filters for lower level protocols, for L4 protocol, like I don't know, like a Kafka or maybe MySQL. All these things exist as well. So the service meshes that run with this proxy can leverage this knowledge from those protocols. The Envoy was designed to be, first of all, fast. Sometimes people say, oh, it's kind of dumb because we're removing one load balancer and putting multiple load balancers. Are we introducing more points of failure for application? So the Envoy was designed to be like a super fast and will not introduce any additional latency for the application. Since it will be running alongside of your application, it's going to be like just a separate process and will be communicate efficiently with your application. And one of the important things that Envoy has from the day one, from the very beginning, is ability to provide information about what is going on in application. So these observability building blocks that developers of Envoy put into the system from the day one, now available for others, so they can implement the different ways how they can extract this information, how they can extract these things from metrics, traces, logs from Envoy. So that would be short introduction. I'm pretty sure many people are eager to see how this works in the real world. So, and I am happy to oblige. So let's take a look what is going on here. Let's take a look here. So before we start, I see the Pedro is asking question, how does Kuma compare to Linkerd? So there is a very interesting project, as far as I know, let me find this real quick. Learn KNS. It was, there was a very interesting website where you can find all sorts of interesting materials. They do have resources where you can compare. Remember when I was telling you they're doing some research about the different projects that are available, and they do have a very interesting spreadsheet, like like everything in this life, financial industry, and now it's IT industry also hold on the spreadsheet. So this is the very good, if you want to have a check boxes, not from vendor, essentially. This stuff that coming from some community, and you can find different check marks. For those of you who are asking this, that's what my answer to you. I will post this in YouTube chat, so you will be able to. Essentially, that's Google Doc that include this information. I will also post this in a platform. So this will include a lot of good information for you. But let's get back to our deployment. So Kuma itself comes with a UI tool. So this control plane thing is running right now on my Kubernetes cluster. And what I can see here, so let me quickly refresh just to make sure that I'm showing you the right thing. All right, so now it looks much more nicer. So like I do have one service mesh that is deployed here, and there's a couple of things that we can see here. So first of all, let's take a look how many services we have it here. There's different services deployed. I do have my microservice architecture applications deployed. This microservice architecture, let me show you this. You can actually go there yourself and click around. It's going to be this URL. This demo uses the microservices demo that Google Cloud Platform developed and includes multiple services in the different languages. The most important is those services communicate to each other through gRPC. And for example, this is the service that shows me different items. I can put this in the cart, and after that, it will invoke cart service. From the cart service, I can extract this. I can place an order. So that's my application. So basically every screen on this page is its own like microservice, and the front-end application communicates this. So, but how I would know this, how I would discover this type of information. So first of all, let's take a look to our data plane. So remember, data planes, it is a components that run alongside with your application. That's your proxy. And we see there's control plane for an ads service, for cart service, for checkout service. This is the Acme Cert Manager thing, but it's not working right now. I just disabled it. So this is a currency service, email service. There's a bunch of stuff. And we're currently interested in the front end. This is our front end thing. And there's a bunch of different policies available. If I go to my mesh here, what I will see right now, there's all things are disabled. So let's enable something to see something cool. So the Kuma itself comes with a command line tool that allows you to install a bunch of things. So for me, if I go here, say it's my, say, Kuma CTL list. So we can get resources and we can get meshes. Same information is available through command line. So I can get this default mesh and see there's not much is deployed. So let me modify this and enable some of the metrics, because I do have observability. Remember, I was talking about observability, it's an important bit. But if I go to my Grafana, for example, dashboard, what I see here is that my control plane is up and running and everything is fine. But if I want to see any changes in my mesh, I don't see anything. So I don't see anything. And why is that? Because those things are not available. So metrics are disabled, tracing disabled, and logging is disabled. So let's enable this a little quick by implementing one quick thing. So you can operate with mesh as a cloud native resource. You will be able to operate with this through this how it's called, a manifest. And Kuma installs a bunch of different custom resources. In this case, one of the custom resources is mesh. Inside the specification, I can enable a bunch of things. So first thing, I want to enable logging, and Loki is supported here. I believe Logstash is also supported. I will enable metrics, so it's going to be my Prometheus is going to be my default reporter. And also I will enable tracing using Jaeger. Zipkin Jaeger supported, but also Datadog is supported as well. And in my, I also will implement one traffic trace. So in this case, all this communication between the services will be captured by a Jaeger collector. So this is where I will implement my observability to this. So now it's up and running. So let's go and check the mesh information. So if I go see here, I can see that logging was enabled through Loki, metrics available from Prometheus, and the tracing through Jaeger. So if I'll go here, for example, traffic traces, let's see that all the traffic would be this traffic trace that I just enabled. So let's take a look if our application connectivity changed somehow. So I'm going ahead here, going back, refresh my screen, going into my dashboards. In this particular case, it's a Kuma mesh. And now I start seeing the metrics that service mesh collected from me. So let's take a look quickly. So what is going on here? So let me stop this auto refresh. And now we see that our front end service talks to currency, talks to card service. So every time when I go and click around in this app, it will generate some additional traffic. And say like add to cards. We can go and put this guy, couple more. Say we want to do this 3, add to cart, going back to card service, and after that we do a checkout. Just a quick refresh. And this is where we can see all this communication. We also will be able to see, let's do less 5 minutes, so our graph would look much nicer. So that's a traffic based on the different services. And imagine, and you can see here that those services were, discovered, and the connectivity now between services. I can definitely observe this type of stuff. So next thing is that, let me check if I have enough data sources. So I have a Jaeger for my traces. Let's explore different traces. If I go to Jaeger and I'll just do search, choose, and I choose, for example, front end. I'll just do, let's see if any traces available for a front end. We're running this right now. Is everything good? And from the front end, for example, I was calling the currency service. Let's see what's the service. We can go into Kuma mesh, and we're going into, say, let's see, we have a checkout service. Checkout service is made important because it depends on email service, it depends on payment service, and let's see if we can see the traces from checkout service. Checkout service, just run query. Let's see if there are some other cool dependencies. Yeah, we see there's dependency on email service, on the card service, and we can see the this trace. So this is we can learn a bunch of things here. For example, this information was reported also by the proxy. We know that it is a gRPC protocol between those services. So those things are like immediately available in my application. The way how I can enable this, usually Kuma is good on discovering what type of services. However, you can provide a little bit advice. For example, in this particular case, I do have a service where I put special type of annotation, say it is a protocol gRPC. So in this case, correct, not the generic rules will be applied, but the rules related to this service will be applicable. So that's the metrics. That's the traces. I showed you metrics. I showed you some of the bunch of things around thing. So you can also get a metric from the control plane itself. We know that the control plane is alive right now. We know like the many things is going on here. We can see the latency. So XDC is the protocol that I used to communicate with data planes. I also can see in these things how I can the service to service communicate. Say, for example, my data planes, and I see all these data planes communicate to this one. So it's uptime for some time already. So I just deployed this this morning. Deploy this fresh. So that's data plane for particular service. Let's see what's our checkout service. And this is our data plane for checkout service. Now we can see what's the traffic here. So which is pretty good. There's a lot of information that allows you to deploy your services with confidence, and you will have these observability tools. There are other cool things that are available here. For example, circuit breakers that allows you to design the policies, how your application can stay resilient to some of the failures. So that's why circuit breaker would be like very, very, very important here. And last but not least, I started this conversation about load balancer. It just like let me bring this conversation back home. So there are different data plane proxies. One is the standard, meaning that inside your mesh each individual service will have its own data plane, its own small Envoy proxy. However, when we need to provide the external access, the Kuma integrates with Kong, which is some people call it the API gateway, some people call it proxy. It's everything. So Kong can be your gateway to your system, and Kuma can like provision this. So this is my Kuma gateway, Kong gateway that actually serves the traffic. So right now, when I go and check the headers, I see that all my traffic that goes into this service actually served by Kong. So I use Kong in this particular case as my ingress controller that allows me to communicate with all these things. So let me quickly show you how this ingress look like, and it's also like allows me to do things with TLS, enable HTTPS and things like that. So it handles this nicely. Different plugins available. So if you want to learn a little bit more about this stuff, next week we're going to be running Kong Summit, where we're going to be talking about all the things in details. Like, I really encourage you to join. It's going to be free. It's going to be a lot of cool information, and you can always subscribe to our YouTube channel in Kong YouTube channel, where I post some of the materials that to educate you. I post some of the material to explain some of the concept, and we're going to be running these the weekly live streams where we're going to talk about things about cloud connectivity, Kong, and some other service mesh and other concepts. I hope you enjoyed this presentation, and I will be waiting for your questions. You can always reach out to me in Twitter. This is the preferred place for me to find all of you, and you will be able to find me there as well. And with this, my name is Viktor Gamov, and as always, have a nice day.